All right, so today we have Steve Pike. He is the co-founder of Infield.ai, one of the most exciting startups I've actually come across recently, and you'll find out why. So the way they describe themselves is upgrade confidently, and also Infield combines automation with a team of expert developers to upgrade open source software safely. So with that, Steve, welcome to the Data Exchange podcast.
Thanks for having me.
All right, so let's start with the basics. So what is the problem you're trying to solve?
Yeah, so Infield upgrades open source software dependencies, and then we keep them up to date forever. So the problem is companies build on top of open source software. So in any software application being built today, you're commonly using 4 lines of open source code for every line of code that your developers write. And all of those open source projects get new releases over time. So new versions come out for new features, fixing security issues, addressing bugs. And you're tasked as the developer of keeping all of those different dependencies up to date as new versions come out.
And of course, you're a startup founder. So before you started the company, you must have measured the size of this market. So give us a sense of how big this problem is.
Yeah, the problem is huge. I mean, it's a problem that affects every software engineering team nowadays. We've you try to estimate these markets. It's estimated that if you take a average team of 10 software engineers, usually have one person on kind of maintenance rotation every sprint. So you might have one software engineer tasked with spending one day every 2 weeks doing this kind of dependency technical debt. So on a kind of like bottoms up size, that's a way to kind of approximate the amount of time people are spending on this problem. From the other angle, you can look at all of the pain that's caused in the industry from security vulnerabilities coming out and companies not taking patches fast enough. And the reason they don't take these patches is that they are too painful to accept, because if I'm on version 1 of a project and a vulnerability came out, but the maintainer is only supporting version 2, I'm not getting a patch for the version that I'm on, and I need to go through the work of upgrading maybe a major project, upgrade this library before I can take the patch. And so people leave these vulnerabilities unaddressed, and so it kind of hits you from both sides there.
So there's so many kind of software trends and I guess for lack of better words, software management practices. I don't know, Agile, Scrum, all of these things. So is this a problem that can be managed away or using processes instead of tools?
In a sense, depending on, it's costly but doable in that sense. So this is a problem that exists because you rely on all of these other pieces of software that are constantly changing, and it is difficult to keep them all up to date because new versions can break your code. And so if you have 100 dependencies that you rely on, new versions are coming out all the time. Someone on your team needs to review the changelog of each of those packages, figure out if it's safe to do the upgrade. If it's not, figure out how your application needs to change in order to work with the new version of this library. And all of that is a technical project management problem that you can handle in various ways as a process. But once you've decided to do the work of actually upgrading these dependencies, then you have to actually have an engineer tasked with going and doing it. And some of these are trivial, you can batch them together, but many of them involve actually sitting down and figuring out how to safely migrate to the new way of doing something that a new version of a dependency requires. And so the major, mostly people do that today by either dedicating, like I said, someone on my team spends some of their time on a maintenance rotation, not building features, but instead addressing this technical debt, or you can outsource it to a consultant or something like that.
So without trashing competitors, right? So obviously when you entered the space, there must have been at least some partial solutions. So what could the partial solutions do, and what were they lacking?
Yeah. Maybe if I could step back and say, so I came to this problem from having it myself running a software company before. So I was CTO at a startup built on a large framework, Ruby on Rails. We were around for 8 years. I left that company feeling a little bit like the the problem of like staying on top of the technical depth of a system like that you're maintaining for a decade is just a thorny problem, and you never spend the time you should to really keep it up to date. And that causes things to slow down as you get larger, and it becomes more and more difficult to change these systems. And so I started to think about solving that problem through a startup. I spent year before that, as a consultant, just like solving this problem by hand for a bunch of companies. So literally, you pay me and I will keep your system up to date. I will upgrade you out of the hole you're in, and then I will keep you there. And so I have a lot of experience through that, kind of seeing the problem and then trying to actually get in and solve the problem. And from that, there are kind of two different angles on solving it that exist out there in the world today. So there's throw money at the problem through people. So you can hire a consulting firm or hire software engineers and just throw them at doing these upgrades themselves. They're generally doing them for the first time. So they haven't seen your code before, and they haven't seen this specific package upgrade before. They're not experts in like this kind of upgrade. And so they just don't have the knowledge of having seen the specific changelog or breaking change that needs to be fixed 10 times before and know what to do. And so they're kind of lacking the data that I think we're trying to bring here. The other attack on the problem is more from the compiler's world, and this is building tooling to make it easier to refactor code. And so there's a lot of work going on, like language model related and not, just on the problem of across a large code base, how do I, if I know I need to make a certain kind of refactoring, I know that this method needs to, let's say, if this method is being called in a thread, I need to add an extra argument that is this kind of thing. How do I search my code for occurrences like that? And then how do I replace them safely? And there are things just like much better than grep nowadays. So there are things that take the abstract syntax tree of your code, which is a way of interacting with your code at like a higher level of abstraction than just like the text in the document. So you take that, and then you can express like a transformation across that data structure. And that technology, I think, mostly started with compilers and then like linters. So if you have a linter environment for a linter is scans your code to tell you whether it's written in like a good style or correct the style. Uses a similar kind of technology to what I'm describing here. So linters were like the first generation, and then there's a new generation of tooling out there that just tries to make it a lot more expressive, a lot easier to describe these sorts of transformations. And so I think that tooling is really interesting, but it doesn't solve 100% of the problem. So it's kind of like useful to enable a person to do this sort of work faster, but somebody still needs to sit down and say, for this dependency to go from here to here, here's what needs to change. Writing down a rule to fix that change is kind of part of that work, but not the whole thing. I think those are two different kind of angles on the problem. The outsourcing angle, they'll solve the whole problem, but they might not be good at it. They might not be efficient at it. And the tooling angle, like very efficient at what it does, but doesn't solve the whole problem. And what we're trying to do is tackle the entire problem. So you hire Infield, we upgrade your application, we keep it up to date, but we're doing it with software. So we combine software and our team of people, but we're trying to turn this problem into a data problem. We know for every package that's out there, for every breaking change that's coming out, what do you need to do about it? And then we take care of it for you.
So let's go more into the how. So I guess it's important to kind of emphasize that for now, Infield is focused on web apps and web frameworks, right? So web teams is the target, but there's nothing to say that the audience for this podcast primarily interested in AI and machine learning and data engineering. That's not something that's far away from your mind, and that those are spaces that you want to tackle eventually, right?
Yeah, totally. We want to tackle all software applications that need to stay up to date. We found, as just like starting with the most acute pain point here, the best early customers for us have been generally they're using Ruby, Python, or JavaScript on the back end, running a server that is exposed to the world, which most commonly now is a web app. Those are the teams that we support, and where they have the generally most like driving need to keep their system up to date, because security vulnerabilities are most impactful, or the risk of something going wrong is more impactful than a data pipeline that you're running internally inside an organization. Not that that's not also important to keep secure, but just as a first who we've seen kind of latch on at the beginning. That's where we're starting.
But all the learnings that you're finding out now, that will map to other areas.
Totally. So we're building up a database of every open source package, every new version of the package as it comes out. We automatically grab the changelog, we automatically parse it, we put it through a language model to structure it, so we know, when someone is releasing a change that actually includes a breaking change and they're violating semantic versioning, right? We can catch that, and then we can figure out what to do about it. And so we're building up that data set, using it ourselves in managing our customers' code bases, and also building out the tooling to handle every code base eventually.
So would Infield been possible 5 years ago before large language models?
That's a good question. The language models are an enabling technology for us going faster, and for us working more efficiently and like a broader scale. But the core idea is, I think, much simpler than that. The core idea is everybody is upgrading the same stuff. They're all doing it for the first time. Let's put all of those experiences in a database. Let's build a data pipeline. Like my background is building a data startup and a data pipeline at a startup before then. Let's treat this like a data problem instead of a compiler's problem. And by doing that, we will not be encountering the upgrade you're doing for the first time when you come up to us to do it. And that kind of model, I think, doesn't rely on language models to make sense as something that should exist in a better way of doing this. I'll say when you're doing this work, if you go and upgrade your own code base without using Infield, if something goes wrong in production and you Google the error message that you got, you will find that somebody else hit that error before. And if that information has just been surfaced to you proactively, you would have been able to avoid it. Now, actually implementing this idea, building this data pipeline that grabs every new version of every dependency, grabbing information about what is changing and what can go wrong, and then surfacing that automatically to someone when they're doing an upgrade, that is all definitely enabled by language models. So I think there's kind of a really interesting intersection here where we are taking all of the unstructured content that is written about code. So we're taking changelogs, we're taking GitHub issues, Stack Overflow question, all of the stuff on the internet that is community generated about changing stuff, about code, but this is all text, and we're trying to structure it to make it executable, to turn it into a set of rules that we can apply to figure out whether your code is affected by a change that's coming. I think that's kind of a cool application of language models, and there's a lot out there around generating structured content, actually writing code, and a lot out there around generating creative content like movies. But we're kind of taking all of the human written text content about code and doing something with it.
So you mentioned some of the basic data ingredients, right? So Stack Overflow, changelogs, release notes. But Steve, some communities are starting to go use tools like Discord and Slack. And what if you can't go in and scrape these things? So does that impact, or are you worried about your access to some of the community?
Yeah,
Yeah.
that hasn't been a problem so far. I think so. Philosophically, we're really trying to go in the other direction of making more and more of this information open. So we're one of the things that I'm excited about is taking some of the information that we've structured and contributing it back to the open source community. So you think about ways to solve this problem of upgrading software safely. You can have vendors of these tooling that you're using to express these patterns, give you kind of a library of proprietary patterns, or you can have the community of open source maintainers write these rules themselves. So when I'm releasing a new version of Python or a new version of Django, should I be, as part of that software development lifecycle, as an open source maintainer, pushing out to the world code that allows my users to figure out whether they're how they need to change their applications to be compatible in the future. So there's a world of kind of code mods or these kind of transformations, and the JavaScript community, I think, does a good job about this. If you go to upgrade React, the maintainers have put out for a bunch of the different changes you need to make, code that's officially endorsed by the maintainer for making these migrations. And I would like to see more of that in the world. So I think we will contribute that. We're encouraging the community to contribute that. If you contribute it, we'll help with the tooling to use it. But so I guess to your point, I think a lot of the conversations around surfacing that these issues exist happen. They used to happen on IRC, now they're going to happen in Discord. But once the issue is surfaced, I would like something to be done about it that is put in the open source project, that is somewhere official that everybody can use.
Well, so when you say surface, so when it reaches some sort of much more formal status, like a pull request or a issue posted on GitHub, as opposed to just a
Yeah,
random question on Discord or Slack.
yeah, this information is not so lost in a haystack. It's not so subtle. These things. We're not trying to find the one comment about something that happened to be written in a Discord channel. If my system goes down and I report it to the maintainer, I want that to be recorded somewhere. Maybe not official, but that gets recorded somewhere permanently. It doesn't need to be mined out of something.
And wherever it's recorded is much more public.
Yes, and it should be, in my opinion. It's part of the open source project maintenance. Now, doing that in a way that doesn't, burden maintainers, like I think it's very fair for an open source maintainer to want to write their code, and they'll listen to the community, but they don't want to be responsible for shepherding all of their all of their users, code bases to their newest version. They want to put out some good documentation and kind of go about, continue adding new features or with what excites them about contributing. So I think there's a balance there around making it really easy to incorporate this information in the project, or using it as a way to get maybe new contributors into an open source project. I think it's a good opportunity for somebody who wants to contribute to open source. You can write documentation, but it kind of is similar to writing the documentation. And now could be, we're writing these, any content that helps with people actually staying on the latest version. I think that would be really useful.
So to the extent you're comfortable, so feel free to refuse to answer this question. But so you get all this data. So take us under the hood and describe what you do with this data.
Sure. Yeah, so happy to share. Again, the goal here, just to anchor what we're using the data for, is we connect to your code. Our team and our software scans your code. We figure out what needs to be upgraded, and then we do it for you. So we open incremental pull requests against your code until you're up to date, even if we need to make actual changes to your application to be compatible with the latest version of these libraries. And our software is doing all the project management of which dependencies should be upgraded in which order. And then our team is actually making sure that the changes are safe and tested. So all the data that we're aggregating is kind of in service of that, what we're trying to build there. And so when we connect your code, we figure out all the dependencies that you rely on. And we're talking about application layer dependencies here. So stuff that's installed with pip or poetry or npm, yarn. Find all those dependencies. We put them into a data pipeline where someone on our team actually goes and researches them once. So we find the official, GitHub page or GitLab page or maintainers page, where they keep information about this dependency. We vet whether it's still maintained at all. So is this dependency abandoned? Is it actively maintained? Is there a fork of it that we should suggest people move to? And then we also set up automated ingestion of the release notes and other information as new versions of that dependency come out. So that's all kind of the input into our system. From there, it's automated. So from there we take that release notes of new versions of these dependencies as they come out. We run them through a language model. We categorize them as for the kind of risk and for the risk basically to your application of taking this change and breaking it down into discrete changes. So say, you're going from version 1 to 2 of this dependency, you'll hit 7 breaking changes. Here is what the maintainer maybe suggests that you do about them. Here is a pattern to check your code, whether you're affected. We produce that. And then we do a sampling kind of review of the output with our team to make sure that there are no mistakes. We take that output and we use it to then manage your code. So we can, one thing you can do with that output is give me all of the dependencies that can be upgraded safely within this project. So give me all the, across the 100 dependencies you rely on, maybe there are 50 that we can upgrade, where if the tests pass, there are no breaking changes that you need to be worried about, so we can just get those out of the way. But here are other dependencies you rely on that even if the maintainer claims they support semantic versioning, actually we know there is a dangerous issue in this upgrade. So we're going to do that one. We're going to have a person look at that and actually make sure it's safe. So it kind of goes into that planning and then upgrade process from there.
So I assume everything is happening in staging and not in prod.
In terms of how we affect our customers' code?
Yeah.
So we fit into the normal software development process there. So we open a pull request, we run tests, we get our changes accepted, just like an engineer in your team.
And in the course of the year you spent consulting on this problem and now building Infield, what are some of the key learnings in terms of what would be important in the UX, in the user interface that developers are really appreciative of?
Yeah. So what I've learned is customers really love us solving the entire problem. So they are way more excited about Infield digs me out of the hole and then keeps me up to date. Even if that means that we have to pay for a developer on their team to be making changes to our application, that is a way more compelling offering than here's tooling that your team can use to manage your upgrades yourself. And so that's like a major learning that I have in doing this for the last couple of years here. I on the software development side, I have been kind of surprised and also it's been really interesting to learn the semantic differences between all of the different ways that package management is done out in the world. So if you look at the way that JavaScript package management works versus Ruby package management or Python package management, or all these different even these are all dynamically typed like interpreted languages, even just in this world, and all relatively like widely used. I think all used for like can all be used for web apps. Even within this world, the JavaScript package managers will allow you to install multiple versions of the same dependency at the same time, and the Ruby and the Python one just won't. And so the way that relates to building kind of universal solutions to this problem of keeping everything up to date, that's been just like a technically interesting kind of challenge for us to work through on our side.
Yeah, I think I shared this with you the last time we talked, which is basically even single pieces of software, right? So like the fear of upgrading to a more recent version of Postgres, for example, is a huge kind of blocker or psychological barrier for a lot of teams.
Yeah, it's really psychological, and it's also no one really gets promoted for upgrading Postgres. They get fired for being on Postgres 8 in 2024 and like not having any support for their even I don't know, I'm not even sure which the oldest supported one is at this point, but I know it's 9 is not supported. And a lot of teams let this stuff linger until it becomes required that they upgrade, and then someone does something about it. And that means we're on a version that's not supported at all, or we're on a version that doesn't run on a supported operating system, or we can't hire because nobody wants to work on Python 2 anymore. And so there is definitely something to, or I guess, and the other thing we found is that situation of letting these things linger is often true at organizations with otherwise like pretty strong engineering culture. Like often we will talk to companies where there are individual engineers internally, senior engineers who are great developers who it like pains them in their soul that their company hasn't done anything about these problems, and yet they can't get it, the time budgeted to actually go through the process of doing this stuff safely. And that makes sense from like an organizational risk assessment, because you can run an old version of Postgres for a long time safely, maybe not an unsupported version, but certainly a couple of major versions back. And so in the trade-off between having your and it is risky to touch some of that stuff, because you have an important application, and this is your database, or this is your language, these are like fundamental things that you're relying on, and so the only thing that can happen when you change them is something goes wrong, is one way to think about it. There are often benefits to upgrading, but they're performance benefits and things, but not really the core thing. And anyways, we talked to these companies, they have these people, these great engineers who want to be upgraded, and yet they aren't. So I think that is kind of an interesting just part of these organizational dynamics.
So looking ahead, so how do you think the role of AI and machine learning will evolve as far as the areas you're interested in, which is software development and software upgrades?
Yeah, I think it's going to be hugely impactful. I think for the efficiency of the person who is doing the actual work. I think we can make a copilot for upgrading software that makes the work much faster and much safer. Excuse me, because it proactively surfaces to you what you need to be aware of in doing this work. And I don't think we're there yet. I think the it requires kind of two things. It requires the data that we're building, like what are all the actual examples of changes that are being taken and whether they're successful. What needed to be done to an application to make it compatible with a new version of something, like getting all these before after examples. And then the second thing is continuing evolution of the actual code refactoring technology that's out there. So taking an entire code base, putting it into a model context, and then being able to manipulate it based on the information that we're gathering here. I think both of those things, as they evolve, will get us closer to being able to totally automate this work.
So I guess one other question about how people end up using Infield. So you start using Infield, you start addressing some of these pull requests, but I guess at the end of the day, before you finally hit your production systems, you go through all the things you normally do: unit tests, integration testing, all the tests, all the QA processes remain in place, right?
Yes.
And so again, going back to the subject of AI, I guess you guys are human in the loop and will always be human in the loop. So I guess one easy prediction would be the humans will do less and maybe be able to help more companies. One human on the Infield team will end up engaging with more and more projects.
I mean, we think that we're not going to take the human entirely out of the loop for a long time here. Even if we do, I think our theory is the right way to build that is to build the data that we're building by doing this ourselves. And so, we're going to get to that point, however we get there. What we're trying to do is solve the entire problem from the beginning, filling in the places that we can't do automatically with people. That's a larger percentage at the beginning. And then over time, we are peeling off, pieces and pieces that we can automate. And the scope of what we can peel off, it'll continue to expand as we improve the tooling.
And then expanding beyond web applications to, say, ML and AI applications. So you folks already handle Python, and Python is huge in AI, right? And we hear
so we can do this for Python applications. So we can do it for machine learning applications. We found that our earliest adopters have been running web apps as just like the people who have felt the pain the most right now. Yep.
Yeah, and the people who will pay for the services. But I think increasingly as more applications become AI applications, then there'll be more people willing to pay for a service like Infield. And in the AI space, because of Python, you've got this huge kind of problem around the Python supply chain, right? So software supply chain, where people are installing things where they don't know all of the dependencies. And it actually, when you get curious about a model, sometimes you end up not upgrading because some of these dependencies start breaking your model, right?
So having there's a lot to unpack there. I think there is and as far as Infield goes, things that I'm excited about. So we're starting kind of tightly on the problem of upgrading open source dependencies, and specifically upgrading application layer open source dependencies. We're naturally expanding both to doing more with your application dependencies. So the same data that we're gathering, we can use to recommend things to you, like switching away from one dependency to another, or you're using two different dependencies in your application that for the same behavior, and so we should consolidate to one. Or all this work around kind of like not just keeping things latest for being able to take security patches, but kind of what's my open source dependency strategy generally. That's like one horizontal expansion that we're right in the middle of. The other thing that we're definitely going after in the medium term is the rest of everything that you consider a dependency of your project. So like Postgres, right? That's not a application layer dependency. You're not like linking against it or installing it with your package manager. But if your web application relies on a Postgres database and it's running on Kubernetes, or it's running on Heroku, or it's and so it's got you've got your operating system dependency. Maybe you have a Memcache or a Redis server. You've got all these different service dependencies and like operating system level libraries that are also necessary for your application to run. All of those are changing over time too, and so we want to be able to map those out and keep those latest as well.
So one of the things I like about what you guys do, in software, you always have this build versus buy, right?
Yeah.
And someone listening to this episode might say, "Well, based on what Steve described, I can just build this myself." But the nice thing about what you guys do is actually no one wants to build what you're building.
Yeah, I mean,
And also as you point out, I guess you can kind of get rewarded if you pull it off, but it's not exactly core business problem, right? So
yeah, exactly. Now there are lots of organizations out there that have large platform engineering teams or internal like DevSecOps teams that own this problem and they've hired for it and they've built their own tooling. They're not going to be those aren't going to be the first companies to adopt Infield. They've built their own solution to this problem. It's not the majority of the companies, and ours will be better because ours is better because this is all we do. But there are people who build this themselves. But by and large, nobody really wants to. This is not work that should be a competitive advantage for your team. And in fact, it's like the worst kind of work to be doing because you're doing exactly the same work in vetting and upgrading some dependency that every other company is doing that relies on the same dependency. None of you are good at it because you're all seeing it for the first time, and we've seen it 100 times. And so and it's taking your team time away from building features that they should be building. And so really nobody that we talk to says like, I love my team doing this. They might say, my team has to do this, and so I want to, or you can make justifications after the fact for learning that your team gets from doing this work. But yeah, it's good stuff to take off your plate.
I think I mentioned this to you the last time we spoke, which is you should start speaking at security and compliance conferences, right? So what's your relationship with those communities, and do they know about Infield?
Yeah, we haven't gone and talked to the conferences yet. We've definitely been asked how do we fit into that landscape, and so we do get a lot of interest from like CISOs or from the security side of the fence. So if I get hired as the first CISO, I'm coming into an organization trying to implement a security process. I run one of the things that I want to do is run a scanning suite like Dependabot or Sneak or something that checks all my application dependencies and tells me what's vulnerable. Once I do that, inevitably it spits out dozens or hundreds of things that should be done, should be triaged, should be addressed. What do I do with that? There's tooling that like I can buy that lets my team triage that list, sort of efficiently, like kick things out if they can't actually be exploitable in my environment. But if you actually want to get this stuff upgraded, you have to go to the product side, engineering side, and get them to do the work. And so we've kind of come in the door that way through organizations where there's a leader on the security side who doesn't have the ability to do this work themselves, and they get excited about what we can do and then pass us along. But ultimately we are selling to the engineering side of the house. We are once they've made the decision that either someone on that team is going to be doing this work or they're going to have someone like us involved, then we're talking to them.
By the way, what you just described there is kind of scary, right? So I'm a CISO, I run this tool, I get this list. If I can't do anything about it, and then somehow we get hacked, and then during discovery, this list emerges as, oh, these guys knew that this was a problem.
Oh yeah. I mean, that's a lot. Yeah, and if you're in a regulated space, or depending on your customers, that you can be really unacceptable. And also, it shouldn't be this way. Like, you're going to have to do this work eventually. If you wait forever, eventually you're on totally unsupported versions of these dependencies, and they stop working on your operating system, or a vulnerability comes out and you can't take the patch, and now you have your product development gets put on hold for a month while you scramble to upgrade major versions of something. That's like a terrible position to just like wait to be in. Or on the flip side, if you do get to the latest version of all your dependencies, then patches are trivial to take. So you almost don't even need one of these security scanning tools because you're just upgrading all the time, right? So it doesn't matter the criticality of a CV that comes out. You should just take the patch, right? And you don't need to think too hard about taking the patch because you're close enough to the latest version that the only change you're accepting is the specific patch that came out that is totally safe. And so our customers get to that point, and then everything becomes a lot easier to maintain going forward.
So have you run into the situation where, okay, so someone uses Infield, they get all of the advice, they try to follow it, but it just won't work for whatever reason in their app? I mean, they can't take the latest patch or the latest upgrade.
No, that hasn't happened. What's happened is there are different priorities in different organizations. So there are definitely I would say medium, large, profitable applications out there with a philosophy of kind of keep it running, like skeleton crew. So like, we want to make sure that our system doesn't get hacked, but otherwise we basically want to do the like minimum amount we need to keep this thing supported. And so their target is not being absolutely latest in everything. Their target is be on supported versions that will receive patches, make sure that my code is compatible with a supported version of the operating system I'm running on. And so you might change the target that you're trying to achieve, and be a little looser with what we would say recommend for a team to take. But no, this is work that can be done. Like, it takes time. Like, it takes it. And actually, another thing I would say is it's not really software engineering work. It's really like research, risk assessment, and like almost like mundane kind of meticulousness. Like, you need to go to some new version of a dependency. There are 10 changes. You need to review your code to see whether you're affected by the change. You need to run maybe some tests, maybe some manual tests. You need to, have a good feeling, test and staging. Just like working through the project of safely getting to the latest version. It can be done. It might require changing a bunch of files or something, but it's not inventing. It's a different kind of difficulty that I think lots of software engineers don't want to do. It's hard work, but it's a different kind of hard work than what they might be used to.
So what's on Infield's near-term roadmap? So let's say 6 to 12 months. What should people expect?
Yeah, so we're really excited about starting to contribute some of the data that we've collected back to the open source community. So some of the stuff that I talked about before about how I want this to work. I just want the open source community to have a place where they can express these changes in a way that then gets used automatically by tooling. So instead of just writing a changelog, if someone is willing to do the work, we'll do some of it, maintainers will do some of it. I think new contributors will do some of it. If you're willing to do the work, to write down in code, here's what's changing in this new version of a package. We should have a place to put that, and we should have a way to run it. And we have a bunch of this from the work that we've been doing that we're packaging up and excited to open source. And so yeah, just kind of generally giving back more to the community and building out more tooling there on our side is something I'm excited about. Our approach in that is going to be anything that an individual engineer on your team would use in doing upgrades themselves. If you didn't want to use Infield, we'll open source that. But then when you want us to do it for you, that's where the paid service comes in.
And as far as the expanding to other domains besides web apps, that's going to be driven by customer demand, I take it.
Yeah, we're ready to do Python today. If somebody has a machine learning pipeline that they want managed, like we're technically ready to do it. Just we've found the most pull from the web app side so far.
So in closing, you're a serial entrepreneur. Your previous startup seemed a little more on the horizontal platform side, right? So the data startup. I like this because this is very focused, very application specific. So what are some of the lessons you want to tell our aspiring entrepreneurs in terms of, by the way, for our audience too, Steve has been through YC once or twice, right? So
once, yeah. So my background is, I was the first employee and then CTO at a startup in New York in the beverage alcohol industry. So connecting to all of the wholesaler inventory management systems and doing interesting stuff with that to help that as a vertical kind of software for that industry. Then founded a company in the data space that we took through Y Combinator that we eventually actually pivoted to Infield. So that's how we got to here. We could do a whole nother interview on what I've learned over doing this for years. I think
well,
I don't know if there's anything technical that I want to say. I think mostly what I've learned is, and maybe I take some of the technical stuff for granted because I'm a software engineer and I can write the code that the first beginning code for the company. But most of my learning is on the business side, and most of that is around making sure that you're solving a problem people will pay you for from the beginning, at least for what the kind of companies that I want to build, and where I get my motivation from is I feel really good that our customers are happy for us to take this problem and solve it for them, and that we can prove we are by their willingness to pay us for it. And so for me, at least, that's been motivating and something to kind of anchor on as we figure out what to build.
So one of the challenges with what you said, Steve, is a lot of people out here, at least in the Bay Area, right? So they write something for their friends, but their friends work at tech companies that don't pay for anything.
Yeah, I mean, I think that's like a different kind of company. I think, especially in developer tools, that's a very common kind of company. For me personally, that's not the kind of company that I set out to build. I think I love open source software. I think I would, in a different life, just write open source software and give it to the world. I'm not trying to build a company where I give it stuff, I give my core thing away, get a lot of people using it, and then monetize it later. I'm trying to say, here's a problem that we solved from the beginning. You pay us for it. We know that it's important.
Plus, as you described earlier, you did your homework. You did a year's worth of actually trying to solve this problem. And in the course of that, you understood what the problem was and that the problem is real, right?
Yeah, totally. That was a very validating experience to go through. And also, even on just doing it with a handful of half a dozen customers, I already ran into situations where I was doing work that I had already done before. Like 2 or 3 times, I had hit the same change that I was now, shepherding through. And so it just became so clear that this work can be done a lot faster and better, safer.
So if you don't mind me asking, Steve, during that period, were you consulting with, I guess, what would be the advanced companies or regular companies? You know what I mean? So in terms of technical sophistication.
It was a range, actually. It was primarily Series B, C stage funded startups that had been founded at least 4 or 5 years prior. So established companies with 10 to 50 engineers on the engineering team, growing quickly. That was the core group. There was one early stage company that was only founded 2 years ago. Project went well, but generally speaking, if you're a fresh enough code base, you haven't encountered you should use us because you should try to stay out of ever being in this thing on the whole again. But you might not have learned that yet, like deeply. And then we had one experience with a company that really wanted more of a maintenance mode. Like, we've got an application, we have no software engineers on the team, but we just want to keep this thing running, stable, secure forever in production. And can you keep it up to date enough for that? Just kind of hit a couple different types of companies through that work.
So did you supplement this kind of actual work with just interviewing people, just reaching out to people and conducting kind of almost like ethnographic studies?
A bit, particularly on trying to figure out what the tooling and process out there is for companies who are doing this themselves. So did talk to a bunch of like director of engineering kind of title people at the kind of common stage company we were working with, particularly for companies that were handling this themselves around, when I said at the beginning, a lot of, a rule of thumb would be like one person on each team is spending 1 day a sprint on this kind of like technical debt. That kind of information came from talking to a bunch of engineering managers about how they tackle this problem if they handle it themselves. So got a good sense of like what you do on the people side to do it by yourself and what tooling they were using, whether it's useful. We did that kind of research, but for me, having had this problem as a CTO that I wanted my team to solve, and then actually solving it for companies myself as a consultant, like that gave a lot more information towards how I wanted to actually build the company.
So, I mean, I imagine this problem is huge in regular enterprises, Fortune 500, Fortune 1000 companies as well, right? I mean, they talk about legacy systems, right? So,
yeah, we'll get there for sure. I think we found that we don't have customers of that. We have customers with large code bases and doing large amounts of revenue, but we don't have the kind of Fortune 500 enterprise teams on board yet.
And because a lot of what you do is kind of presumes open source, right? So,
yeah, it presumes your company is not open source, but you're building on top of open source software, which I think these companies are, but
are now. Yeah.
They are now, but yeah, I think they'll come in.
Yeah. And with that, thank you, Steve. This has been great. And again, the company is at Infield.ai.
Awesome. Yeah. Thank you, Ben.